everyone, it's John Galante, president of AE Ventures, here with another of our Builder Innovator webcasts. We're actually filming live at the Builder Innovator Summit Spring 25 in Orlando, and I'm joined today by Jonathan Simon, who's the head of residential plumbing for FlowGuard Gold. And what we're going to cover today is a nice comprehensive walkthrough of really features, benefits, advantages of the FlowGuard plumbing system. So Jonathan, let's just kick it off with a little bit of a primer about FlowGuard Gold.
Absolutely. FlowGuard Gold was actually invented in 1959. So it's one of the oldest original non-metallic plumbing systems. It's an advanced CPVC system in its current form. So we've evolved and innovated the product over the last 60 plus years.
Yep.
And we have a copper tube size pipe, which is 1/2 inch through 2 inch in size. For builders who are using larger systems, multifamily buildings, hotels, things like that, you can actually pair FlowGuard Gold with our Corzan Schedule 80 CPVC system for risers and mains where anything larger than 2 inches needed. FlowGuard Gold has become America's leading alternative to PEX and copper systems. What's really unique about FlowGuard Gold is I don't work for a pipe and fitting company. I work for a specialty chemicals company.
Yeah.
We make the chemistry that goes into the raw materials and becomes the pipe and fittings.
Gotcha.
So we work with partners who produce FlowGuard Gold pipe and fittings and sell that into the market.
And who are they?
So you can work with Charlotte Pipe, Wavin, also known as Bow, Crestline, and Nibco. They're all partners of ours manufacturing FlowGuard Gold pipe and or fittings. That really creates a lot of opportunity in the marketplace because when you specify a FlowGuard Gold system, you're not locked into a single manufacturer.
Yeah, so been around since 1959. This is a big global company.
Absolutely.
Yeah.
So FlowGuard Gold is our United States product. It's sold in the US and Canada,
Yeah.
but we have a footprint all around the world. Our sister products are sold very heavily in India, in Mexico,
Yeah.
and elsewhere.
So hundreds or thousands of people working for the company and lots of business locations, yeah.
Absolutely. We've got a very large business, and what's really impressive is since 1959, just in the United States and Canada, we've had over 13 billion feet of pipe installed.
Wow.
That's enough to reach from the Earth to the moon,
Yeah.
I believe 12 times. Somebody can fact check me on that.
Very good. So let's talk about some of the features and benefits that are the reason why you're selling all those miles and miles of pipe.
There's lots of benefits that people get from using a FlowGuard Gold system, but we've distilled it down to the 4 key ones: water pressure, installed cost, water quality, and chlorine degradation and chlorine resistance.
Cool, let's knock them off one by one.
So a lot of folks will ask, how does a plumbing system improve your water pressure? And it really comes down to the fittings and how the fittings are designed. In a FlowGuard Gold system, the fitting actually goes on the outside of the pipe, so it provides full flow characteristics. Whereas with PEX systems, all of the fittings are inserts, which restrict the flow. And when you do add a flow restriction, it costs the system in pressure.
Yeah.
So as you can see on the chart that we're showing, a FlowGuard Gold system is 27% larger at 1/2 inch diameter than the largest PEX fitting, and 57% larger than the smallest 1/2 inch PEX fitting.
Yeah.
I talk to a lot of builders and a lot of plumbers who say, well, I only specify expansion style PEX because the flow restriction of the crimp style is too much. They are often shocked to hear that the difference between FlowGuard Gold and expansion is larger than the difference between expansion and crimp. A lot of folks blame low flow fixtures, but low flow fixtures often aren't the problem. And I think everybody remembers the Seinfeld episode from the 90s where they were looking for the elephant shower head. And it was...
Was that the same episode where he was cleaning the lettuce in the shower?
It may well have been. Okay. But one of the things that we see in the modern era, low flow fixtures have figured out how to do the best, how to really create the best possible experience for the homeowner as long as the pressure and the flow is getting to the fixture.
Yeah.
When you have an undersized plumbing system that has a lot of insert fittings like you might see in a 1/2-inch PEX system, you're losing a lot of water pressure. And that flows into this issue of velocity restrictions.
Yeah.
So when you're running with a FlowGuard Gold system, it can run at 8 to 10 feet per second in both hot and cold water.
Yeah.
Without any other restrictions. Copper pipes, which is what a lot of folks compare to in terms of their experiences growing up, and that's their baseline comparison, is allowed 8 feet per second for cold water, but only 5 feet per second for hot water. And PEX systems add another layer of complexity. So for cold water, they'll match with FlowGuard Gold at that 8 to 10 feet per second. Hot water is limited to 8 feet per second maximum. And if you have a hot water recirculating system, which is increasingly popular under environmental codes, and it helps to reduce wasted water and get you faster hot water delivery, those systems are actually limited to 2 feet per second. And when you have to slow that water down to 2 feet per second, it has a lot of impact on the performance of the system. It takes a longer time to flush out all of that cold water before the hot water gets there.
Yep.
And it can result in needing larger diameter pipe to get the volume to the fixture that's required.
Right.
One of the places this really pops up where we see a lot of complaints is in luxury showers. Luxury showers that have multiple body sprayers and heads and the power wash type experience that Lisa was talking about.
Yep.
They require a very specific balanced design. Otherwise, one sprayer will be blowing the water out much harder than another. It creates an unpleasant experience.
Yeah.
So to do that, you have to hard pipe it with lots of elbows and T's. With a PEX system that uses insert fittings, every time you put an elbow or a T in, it's going to cost between 2 to 5 psi of water pressure. The corresponding FlowGuard Gold fittings will cost less than 1/3 of a psi of water pressure.
Yep.
So when you take into consideration the full design of the system, doing it with 1/2-inch PEX could cost 30 psi. The way that they get around that is to upsize the pipe. Instead of running that with 1/2-inch, you might need 3/4, sometimes even 1-inch pipe.
Yeah.
And if that's what you need at the shower, then all of the pipe feeding into that system has to be larger to compensate for it as well. You can't go from a 3/4-inch main into a 1-inch shower.
Yeah.
So that adds cost, and it also slows down hot water delivery, and it can increase the water wasted as you let that cold water just go down the drain, not being used.
Yeah. Well, very cool. So it's not just the user experience. There's a lot of other dollars and cents benefits and save the planet sort of benefits, right?
Absolutely. It's great for the homeowner, it's great for the builder economically, and it's good for the environment.
Yep. Tell us more about the lower installed cost piece.
This is a real controversial topic in the industry.
Yeah.
Because cost varies wildly across the country, and everything is based off of how people buy.
Yeah.
But we've looked at this broadly. We've looked at both internal studies, third-party studies, and even our competitors' research. And what we've found is that in a trunk and branch style system, which is the most common way that a plumbing system is laid out, FlowGuard Gold installs up to 17% faster than PEX systems. And if you're comparing it to copper, it blows it out of the water.
Yeah.
I don't want to even tell you a percentage because it would sound ridiculous how much faster we are.
Yeah.
But not only is it faster, but what we find is that it can actually be less expensive on materials as well. So that chart on the slide actually comes from one of our competitors in the residential plumbing space, and they analyzed, this was for, I believe it was a hotel job. They looked at the material costs for the main floor, the units, and the risers, and came up with a comparison of their system at almost $21,000 and a CPVC system at just a little over $10,000. I'm not going to promise anybody you're going to save 50%, but there is a significant material cost savings. The fittings are a huge factor in this. Just like it is with water pressure, a FlowGuard Gold fitting usually costs about 1/5 of the corresponding cost of a PEX fitting when you include both the body and the rings that have to be used to assemble it. We actually do have a few more fittings than a PEX system. PEX is more flexible than a FlowGuard Gold system. That's one thing they have on us. But the assembly of those fittings is also significantly faster. A FlowGuard Gold fitting takes approximately 30 seconds to assemble at 1/2 inch or 3/4 inch. A crimp PEX, which is the fastest of all PEX, takes about 45 seconds to assemble with a trained installer. And expansion PEX takes about 1.5 minutes per connection. And it all has to do with the tools that are required and the fact that you have to expand and crimp. With a FlowGuard Gold system, it's a one-step solvent cement. So it's the fastest permanent joint in the industry.
And you, I would assume, have a broad and deep network of installers, of plumbers who are proficient with the specifics of your stuff.
Absolutely. We work with plumbers all across the country who are trained and expert in running FlowGuard Gold. And if there's a plumber who's looking to learn, we have lots of training and resources available to bring someone new to the industry or new to the product and train them up.
Awesome.
One of the reasons I said that this is a controversial topic is you might have heard me caveat at the very beginning, in a trunk and branch style system. There are other types of systems that you can run with PEX that people won't typically run with a FlowGuard Gold. Mini manifold style systems where they'll run a main to a small multi-port T and then drop additional lines to the fixtures. And then there's the central manifold, which has basically that breaker box style and individual runs to each fixture. So when you run those style of systems, it can be a little bit faster. In the same study that we did with the Home Innovation Research Labs, they found that we were 17% faster in trunk and branch. They did show that in a mini manifold system, the PEX would go in about 10% faster. But when we did the material cost analysis, what we found was that while the FlowGuard Gold trunk and branch system needed about 336 feet of pipe, the PEX mini manifold needed 408 feet of pipe. And when you add in the costs, the price difference between trunk and branch and mini manifold went from $219 for FlowGuard Gold to $333 for the PEX mini manifold.
So the total material plus labor costs are actually higher.
Exactly.
PEX.
Exactly. And the reality is 10% when you're talking about plumbing a home, we're talking about maybe 30 minutes. That doesn't result in more homes getting plumbed. It results in the plumber getting to go home a little bit earlier or wherever they choose to go after their day on the job site.
Yeah, gotcha.
I would just like to take a quick moment to talk about that central manifold style system because I run into builders. I was talking with a builder in Texas not too long ago, and they just love this central manifold concept. And they view it as a way that they can sell a convenience to the homeowner. When you run a central manifold system, you can see there are 935 feet of pipe. Plus that manifold can be quite expensive. It boosts the cost to $550. And that's representative pricing. Each individual market will be unique in terms of how things are priced. But the added complexity of that central manifold system is now you've got a bundle of individual lines running to each fixture. So if you've ever seen it, there's sometimes 10 lines all zip tied together running through the ceiling.
Wow.
And that can be a big hassle if there ever is an issue, a leak or something develops in that pipe to try to determine which one had the issue.
Well, you guys have advantages in so many different ways. Let's talk about the water quality piece.
Water quality is a huge, huge issue, and I'm going to apologize in advance for anybody who might be working through their lunch or dinner while watching this, because
is this the gross part of the presentation?
There's going to be a photo that some folks may react to.
Okay.
So one of the key areas of water chemistry and water quality is this question of bacterial growth. There's a property called biofilm formation potential. Biofilms are this slime, effectively, and you can see an example of it in that pipe that grows within a piping system and can harbor harmful bacteria like Legionella and E. coli. FlowGuard Gold and all vinyls, CPVC and PVC, are microscopically smooth because of the chemistry of the product. And that smooth internal surface creates a more difficult environment for biofilms to form. Other products like PEX, a lot of people don't know that PEX actually stands for cross-linked polyethylene. And hopefully this will show up on the camera. Maybe you can get a zoom in editing. But the way I always like to describe it is polyethylene is kind of set up like this. It's a whole bunch of strands of molecules that are linear. Cross-linking meshes them together. And when it gets meshed together, it creates all of these little pockets or nooks and crannies. And that's where small amounts of biological contaminants can settle in, adhere, find a home, and then grow.
And this is piping for potable water coming out of the faucet where these biofilms can form?
Absolutely. Now, it's a fixture that's being used constantly, your risk is going to be relatively low. But if you have, say, a guest bathroom where that faucet's maybe running for 1 week every 6 months.
And the slime is like a petri dish for Legionella and all sorts of diseases.
It's a biological breeding ground, and there's a lot of research that's been done on biofilm formation potential. And so biofilm is this broad category that basically describes the slime and all the stuff that can grow within it. Some of these charts talk about Legionella, some of them talk about E. coli formation.
What's your background? Are you like the scientist, chemistry guy, or what? Or did you just pick this stuff up along the way?
I picked it up through osmosis. I am not a scientist, but I work with a lot of
osmosis is a chemistry term. It's another water term.
That's a Garfield cartoon there. When you look at all this data, in each of these charts, either the lowest or the second lowest biofilm formation potential is CPVC, like FlowGuard Gold. Other materials, copper has really good biofilm formation resistance in the early days, because the copper that it releases as it corrodes is actually biocidal, so it'll disinfect and treat the water. But then it wanes, its biocidal effects wane as the pipe gets older? So if the copper kept releasing copper ions into the water that kill the bacteria, eventually the copper pipe would just corrode through and fail. So what ends up happening is just like there's a patina that forms on the outside of the pipe, there's a protective layer that forms on the inside of the pipe that stops the copper from getting released into the water, but also stops the disinfectant properties. Is the biocidal stuff from the copper pipe good for us to have in our bodies? Is it okay? There's no definitive answer. However, there has been some research that has linked copper corrosion with Alzheimer's disease. And there are some restrictions on copper pipes, what they call the NSF 61 listing. NSF 61 is essentially the standard for whether the pipe is safe for drinking water. And if you have the wrong pH value, most copper won't pass the NSF 61 test. So there are some limitations and safeguards in the systems. Interesting. So now we're getting a little bit deeper into chemistry. This is the fun stuff? So permeation, we're going to talk about permeation, and then in a moment we'll talk about leaching. And these are both different ways that chemicals can get into the water. Permeation happens when chemicals come from the outside of the pipe and work their way through the pipe wall, eventually reaching the water and potentially causing a contamination incident. The EPA did a study several years ago and found that 82% of all documented permeation incidents involve polyolefin plastics. And polyolefin is a family of plastics that includes polyethylene, polypropylene, polybutylene, PERT, and PEX. According to that same EPA study, vinyl materials, which would include CPVC, PVC, and FlowGuard Gold, are virtually impermeable at low levels of contamination, and if exposed to high levels of harmful contamination, would actually fail before allowing the water to become contaminated. That's not to say anybody wants to have a pipe failure, but if I had to choose between contaminated water and a leak, I'll take the leak. That top image was actually taken right here in Florida, and the pipe is been sprayed with a termiticide. And that termiticide is designed, obviously, to kill termites and other insects. But the chemicals in that termiticide, we don't know because there's no research, there's no science being put into that by either the pesticide industry or the PEX industry to say, will that termiticide present a risk of long-term permeation when it's attached to the pipe? Same thing with the spray foam that's there. More chemicals which may or may not permeate. The bottom photo just speaks to how little awareness there is about this issue. That purple-blue color that you see soaking through the bottom pipe is actually the ink that the manufacturer used to mark the pipe with their brand name and code-required print line markings.
Right.
The ink that they used was permeable to the pipe, and they didn't know about it until the pipe had been in service for several years, and then they discovered the issue and ultimately changed how they marked. Leaching, on the other hand, happens when there's chemicals from the pipe that get released into the water. I mentioned before NSF 61, that's the international gold standard for ensuring water safety due to leaching. But not all plumbing products are certified to NSF 61 under all water conditions. So I mentioned before copper has a pH limitation. There are several brands of PEX that have a limitation for what they call commercial hot. So if the water is going to exceed 140 degrees Fahrenheit, they don't have an NSF 61 listing. So it's very important to understand, not just does it say NSF 61 on it, but what are the limitations?
So the materials of the pipe itself break down and become part of the water flow.
Exactly.
Yeah.
It could be artifacts from manufacturing. This next point talks about a chemical compound called MTBE. It's a really interesting story. Back in the 70s, when the high-efficiency gasoline became a topic, MTBE was used extensively in the low-lead, high-efficiency gasoline in the 1970s. What they found was MTBE really loves water, and it would leach out of these underground gasoline storage tanks, causing surface water contamination and groundwater contamination. By the 90s, it was banned from use in gasoline over fears of water contamination. When certain PEX manufacturing methods are used, MTBE can actually be a long-term byproduct. So as the different catalysts break down, they become MTBE. And that MTBE can be released into the water at levels that are above the state-regulated limits. It meets the NSF 61's requirements, but there are state-regulated limits driven by this gasoline water contamination issue that it can exceed for up to a year and a half after the installation of the pipe, after that pipe's been put into service. Eventually it gets down to zero, but that can have some taste and odor issues, and I can't speak to the health effects, but it's certainly not something I would want to experience.
Right.
FlowGuard Gold plumbing systems are certified to NSF 61 under all water conditions, and we comply with all of the relevant state drinking water regulations.
What about water compatibility? What's this all about?
Yeah, so we talked a little bit about what the pipes can do to the water, but it's really important to think about what can the water do to the pipes. So to start that conversation, we really need to look at how do we treat our water. And in the United States, water treatment is really driven by chlorine-based disinfection. So for over 100 years, we've used chlorine in some way, shape, or form. Free chlorine can be used either as a primary or secondary disinfectant. Primary meaning it's not used for the initial kill. Secondary meaning it's being used for that residual disinfection power as the water flows through the system. And it's effective against a lot of different pathogens, but in the late 80s, early 90s, the EPA discovered that chlorine, when it interacts with certain types of contaminants, creates disinfection byproducts that can actually be more harmful than the bacteria that it was intended to kill. From there, we went to chloramine. So chloramine is typically used as a secondary disinfectant, so it's used for that residual disinfecting power. It lasts a lot longer than chlorine, but it takes a lot longer to kill the pathogens. It doesn't have as many harmful byproducts, but it can be highly corrosive to copper piping. There are a lot of incidences in the early 2000s where copper pipe that had been in service for 20 years, homes that were built in the 70s, 80s, early 90s, had been fine. The water utility switches to chloramine, and I mentioned that patina on the inside of the pipe that forms.
Yeah.
The chloramine strips that patina away and causes that pipe to just keep releasing copper ions more and more and more. And eventually that becomes a pinhole leak and results in a failure. But what we're seeing today is this rise in a newer disinfection technology called chlorine dioxide, which can be used as either a primary or a secondary disinfectant. But it's fast and effective against a broad range of pathogens. So even viruses, chlorine-resistant pathogens like Cryptosporidium and Mycobacterium avium. One of them causes stomach issues, and one, when inhaled, can cause respiratory issues. Regular chlorine and chloramine are not effective against those contaminants, but chlorine dioxide is. It also has little to no impact on the taste and odor of the drinking water. There's several cities that have won awards for drinking water quality that are using chlorine dioxide. But chlorine dioxide has what they call a high oxidative reduction potential, which is great for killing bacteria, but it can be a problem for piping. So when we look at how that degradation works, some folks might remember a product called polybutylene. It was a product that was used in the 70s and 80s, came over from Europe. It was gray, flexible, joined with a crimp method, looked a lot like PEX. It was actually the subject of the largest construction product defect class action settlement in American history. There's over $2 billion in settlement funds were released by the manufacturer of the pipe and the fittings because of chlorine-induced oxidative degradation. So what happened was you'd have this chlorine come in, and it would attack the chemical backbone of the pipe. It would break the carbon chain and form a microcrack. And then eventually that crack would expand over time with more chlorine getting in. It would start to snowball, and then it would develop into a pinhole leak. PEX is very similar, where with polybutylene, the branches you can see are all going off in one direction. With PEX, the branches are going off in more of that crosshatch pattern that we talked about before. But there are still openings where the chlorine can get in to that backbone and cause that same level of degradation. So there's been 2 industry notes released on this topic that are very important. The first one was PPI TN53. The PPI is the Plastics Pipe Institute. It's a trade organization that consists of PEX manufacturers, CPVC manufacturers. They issued this technical note 53 that talks about the limits of the existing chlorine ratings. It comes down to temperatures over 140 degrees Fahrenheit, because if anybody who remembers high school chemistry, the hotter something is, the more reactive it becomes. Pressures over 80 psi. So the way I like to explain that is, because PEX is a bit of a ductile material, the higher the water pressure gets, it'll start to push out on that pipe wall, and it sort of opens up those pores. So it starts to stretch it out a little bit and microscopically creates those openings for the chlorine to get in there. And then highly aggressive water, which is defined as water with an ORP, or oxidative reduction potential, greater than 825 millivolts. That was their first technical note, came out in about 2018. And then more recently, in 2023, they issued technical note 67, which cautions against the use of chlorine dioxide in a wide array of materials. Chlorine dioxide, because it has that higher oxidative reduction potential, it's 2.6 times higher than chlorine. So you can get to that 825 millivolts very easy. And that creates a risk to the plumbing systems. So in technical note 67, they walk through a whole host of products, metals and a variety of plastics. And essentially what they said is every piping material, either known to or believed to be subject to degradation to chlorine dioxide, with the exception of CPVC. So there's been several manufacturers that have updated their warranties and their installation guides. These are from installation guides from 3 manufacturers. You can see 2 of them are explicitly saying, do not use our product. We do not recommend using our product if the water has chlorine dioxide for secondary disinfection in it. And then the third is actually referring back to that PPI Technical Note 53 and making those temperature, pressure, and ORP restrictions that are part of Technical Note 53 a part of their installation instructions. So now, if a contractor does everything the way that they're supposed to, but the water chemistry violates these conditions, it's now a violation of the installation instructions, failing to follow the instructions, not a problem with the pipe, but a problem with installation, which is a clever legal trick.
Yeah.
Across the left-hand side here, these are excerpts from the warranties of multiple manufacturers, and this is a subset. But you could look at any PEX manufacturer's warranty, and they will all contain exclusions. So on the back side or page 3, there's a section that says, this warranty is void and does not apply if, and each of these says if there's chemically corrosive or aggressive water conditions that cause the failure, the warranty won't cover it. Some manufacturers in their installation guides will actively prohibit the use of chlorine greater than 4 parts per million with their pipes. But again, the homeowner and the builder have no control over what level of chlorination the water utility is going to use.
Yeah.
And then again, these explicit exclusions for chemically corrosive or aggressive water conditions. So while these warnings are hidden in the fine print, it's all about protecting the manufacturer.
Right.
But plumbers, builders, homeowners, they have no idea when the water chemistry is going to change.
Right.
It can happen at any time. What we've seen in other cases of litigation, and there's been quite a bit of litigation, there's been over a dozen class action lawsuits involving PEX pipe and fitting failures. And typically what we see is the arguments that are made are, either we've excluded this in our warranty, we've warned against it, there's this documentation trail that says, as the builder, as the plumber, as the specifier of the plumbing system, it's your responsibility to be aware of these things.
Yeah.
There was a copper incident I mentioned before with chloramines. A whole subdivision had copper failures within a year of the water utility switching to chloramine. And so the homeowners association got together with the developer and they sued the water utility and said, hey, you changed your water, all of a sudden our pipes started failing. It's your fault, water utility. And the judge threw it out of court. And the ruling was the water utility is only responsible for meeting EPA clean drinking water standards. It is not the water utility's responsibility to ensure that the pipes are compatible with the water conditions. When we look at chlorine dioxide, there's this great data set that comes from the EPA. It's called the UCMR, which is the Unregulated Contaminant Monitoring Rule, for those of you who want to look it up at home. They do a 3-year study of all the water utilities in the country, and they collect all sorts of data, including what type of water treatment they use. As of right now, with the most recent data release, usage of chlorine dioxide is up at least 94% since the last data set, and it's 15 times higher than it was in 2010. Some of this is driven by that increased focus on taste and odor and wanting a better homeowner experience, but a lot of it's also driven by the EPA taking that closer look at those contaminants, the cryptosporidium and the mycobacterium avium. It's driving the need for evolving disinfection practices. These are all utilities that use chlorine dioxide at some point in their system. Some of it may be for primary, some for secondary. Even where it's used for primary disinfection, we find that there's a potential for chlorine dioxide residual to be left in that water system, creating that risk. And this is only 66% complete. So check in with me in early 2026 when the data is done, and we'll fill out the rest of that math.
Okay, we'll issue a notice in 2026.
CPVC, both of the C's stand for chlorine. And what you see on the screen here is a very simple molecular diagram of what CPVC looks like. And you can see all those green molecules hanging out on our carbon chain. When chlorine tries to attack, it just can't get through. It'll bounce off the other chlorines. It won't reach that carbon chain. And if it can't reach the carbon chain, it can't cause degradation. And that's why CPVC as a material is the only plumbing piping material that is 100% immune to any sort of chlorine-based disinfectant in drinking water, causing any sort of degradation. And you can see here that on the left is brand new FlowGuard Gold, and on the right is pipe that was taken out after 20 or 25 years in service in Maryland. And the only difference is a slight color shift that comes with aging.
Sounds like a miracle material.
You know, it really is amazing. Yeah. It is the only material that's immune to chlorine degradation from drinking water. And like I said, over 13 billion feet of pipe installed in American homes and businesses. It is the only proven technology to solve the problem that are caused by chlorine dioxide and these changes in drinking water. As a builder, you just can't control. As a plumber, they can't control it. Yeah. But FlowGuard Gold helps to future-proof those homes against the chlorine-based water disinfectants that are out there in the market.
And the market is speaking on this in terms of your share of market for FlowGuard and
absolutely
CPVC?
Yeah.
Yeah.
We were just looking at an opportunity in Hamilton, Ohio, which is in the Cincinnati-Dayton area. And they've won multiple awards for drinking water quality. They use chlorine dioxide in their water treatment. And we've seen a rash of failures in PEX systems where folks, they didn't know. They used PEX, they were having failures. And now we're seeing builders actively specifying FlowGuard Gold CPVC and prohibiting the use of PEX in the hotels, single-family homes, apartment buildings to avoid these issues because it's a lot easier to solve the problem before it happens than to come back in and get the repipe.
So how can you and FlowGuard help a builder do complete analysis on this sort of stuff? What does that process look like?
Yeah, we are very willing to work with builders. We're working on that map to help identify where chlorine dioxide is currently being used. But like I said, you'll never know what's going to happen in the future.
Right.
We work with builders to help understand the risks. And if the builder has that motivation to work with their plumber to drive a change, we will work with their trades. I know trade availability is a huge challenge for builders. Even if we have a plumber in the area who knows FlowGuard Gold, who loves FlowGuard Gold, your builder may have a relationship with a plumber that goes back 10, 15 years. We'll work with the builder and the plumber to provide that training and education to make that transition as seamless as possible.
Yeah, I think that's so important because the number one thing spinning around in a builder's mind is, I don't want to bring somebody new on the job site. So if you could do that training, and your training would be generic across all 4 of these different brands, right, that distribute the piping. So it provides even flexibility for the plumbing contractor and the builder in terms of brands and negotiations and what have you. So that's cool.
Absolutely. When you specify a FlowGuard Gold system, like I said, you're not locked into a single manufacturer. You can buy from Charlotte, you can buy from Wab & Bow, you can buy from Crestline, you can get it from Nibco. It gives you a lot of flexibility as a builder, and it gives your trades a lot of flexibility as well.
And so do you want people to email you or go to your website or what if they want to dig in?
Absolutely. So www.flowguardgold.com, that's our website. We've got a ton of information there. You can contact us through that website. That'll go directly to someone on my team.
And you like to talk to people. You're ready to geek out on this stuff with people, yeah?
You only gave me about an hour, and I've used just about every minute of it. I could go all day.
Okay. Hey, thank you so much for sharing. I mean, it was not only a product presentation, but a lot of the behind-the-scenes stuff and a chemistry lesson for somebody who hasn't seen chemistry since sophomore year in high school. Thanks so much. We'll see you next time.
Thank you.